Right. The nice thing about the real number line is that it has a lot of properties. And again, just like I said before, that I'm not going to quiz you or test you over specific vocabulary in terms of sets and what goes where. I'm not ever going to quiz you over the vocabulary of, what's the difference between the commutative and the distributive property or that sort of thing. However, in my conversations and my lectures in class and my examples on the board and that you read in the book, you're going to see these words, and so it's a good idea for us to say them out loud and review them to make sure we can keep them straight. Okay. I'm probably not going to say them exactly the way that they are in your textbook, although all of these are found in the colored boxes by definition in the section in your book. But when we talk about the commutative property is true for two operations. It's good for addition, and we can also use it for multiplication. And all the commutative property says to us, and maybe there's two M's in commutative. I'm a little rusty here this summer. But what it says is the order we do these things doesn't matter. Okay, so for example, way back to grade school when you started adding things together, you learned that 4 plus 7 is the same thing as 7 plus 4. We know that we get 11 either way. And then we moved up a little bit to 3rd and 4th grade and we started multiplying things. We know that if we have 5 stacks of 9, we end up with the same number of cards as 9 stacks of 5. We get 45 either way. And that is the commutative property with 2 M's. The associative property is just an extension of the commutative property, and it also is true for both addition and multiplication. And the way the book will write these is with generic A's and B's. So A times B is the same as B times A. Same thing with addition. What the associative property says is if we want to go a little farther, and maybe I'm going to add 3 numbers or 4 numbers or 10 numbers together. The order we do that and the order we group them doesn't matter. Okay, we will still get the same answer. So maybe I'm going to add A and B together first, and then whatever I get from that, I'm going to add C to it. Okay, or maybe I want to add B and C together first, and then go back and add A onto the end. Okay, or I could even add A and C together, and then go back and add B in. Okay, that's the associative property. It's also true if we're multiplying 3 or more numbers together. Okay, I can pick 2, find their product, and then multiply that answer times the third number. Okay. However I want to do that, or again, I could take A times C first and then go back and take the answer times B. Okay, understand that with either of these properties here, it does not work with subtraction. 4 minus 7 is not the same as 7 minus 4. It also does not work with division. 5 divided by 9 is not the same as 9 divided by 5. Okay, we can only flip-flop the order if we're adding or if we're multiplying. And then again, if we extend that on to our groups. Now, when we want to talk about the identities, again, we have identities with respect to the operation of addition and the operation of multiplication. Okay. An identity in this situation is a number that is nothing with respect to the operation that we're working with. Okay. Meaning, if I want to think for a minute, what's the number I can add to anything that doesn't change the number that I started with? And that number is 0. 0 is what's called the additive identity. When we're thinking about multiplying, the number that I can multiply by any number that doesn't change its value is 1. So 1 is what's considered the multiplicative identity. Now, if you think, well, when am I ever going to add 0 to something or multiply something by 1? These identities come into play a lot when we're solving equations. We don't always stop and identify them as such as we're going through those steps, but we use the multiplicative identity anytime we're dealing with fractions. Many of the time, much of the time we're dealing with fractions. Okay, if I have the fraction 2/3, and maybe I don't need it to be over 3, maybe I need 15ths here instead. Then I know 2/3 is 10 over 15, and I determine that by saying, well, if I have a 3 on the bottom and I need 15, I can put a 5 down there. I can only put a 5 on the bottom if I also put a 5 on top. And that's because 5 divided by 5 is equal to 1. And I know that multiplying 2/3 times 1 isn't going to change its value. It's still equal to 2/3. But I've made it look different by picking this funny looking form of 1 here. Okay, so I didn't change its value because I multiplied it by 1, but I definitely changed the way it looked. Okay, so we, again, use these things a lot in our underlying steps, but we don't always stop to verbalize it and call it by name, that that's what we're doing. Any operation that has an identity then has an inverse. And so we have inverses for both addition and multiplication again. When we're talking about additive inverses, if I start with some generic number A, its additive inverse is the number I can add to it that takes me back to the additive identity, which is 0. Okay, when we're talking about multiplication, we're talking about the number we can multiply times A to get back to the multiplicative identity, which was 1. Now, a lot of students with some prompting anyway can come up with the negative A or opposite of A here. If I started with 5, I would add negative 5 to get 0. If I started with negative 12, I would add positive 12 to get back to 0. Sometimes it takes a little more thought for students to come up with the multiplicative inverse. Okay, but if we take A times 1 over A, then we get back to 1. Okay, the relationship or the pair of numbers A and negative A, those are what are called additive inverses. Okay. Now, more often, instead of calling them additive inverses, what do we call them? Numbers like 12 and negative 12. We call them opposites. Okay. And a lot more often in an algebra class, you'll hear, let's add the opposite instead of let's add the inverse. Maybe some teachers use one more than the other, but a lot of students will recognize the word opposite maybe before additive inverse. The numbers A and 1 over A are what are called multiplicative inverses. But more common, we don't very often use the phrase multiplicative inverse. If I flip a fraction upside down, I'm going to call that the reciprocal. When we talk about multiplicative inverses with our real numbers, we're just talking about reciprocals of fractions. So the multiplicative inverse of 2 would be 1 over 2. The multiplicative inverse of 5 over 8 would be 8 over 5. Now, the only property that we really have to do anything with in our textbook, in terms of, that's an R and an I, okay, where there's any arithmetic involved at all, is the distributive property. The distributive property says if we start with a number and we want to multiply it by a sum or difference of numbers, we want to multiply it by an expression. And this is the same thing as taking A times B and adding to it what we get when we multiply A times C. Sometimes it's nicer for us to write it like it is on the right-hand side. As we get a little farther through the book, sometimes we prefer to have it split apart like it is on the left-hand side. So the types of examples we'll see in our exercises is maybe we'll start with 5 times the quantity x plus 3. And we'll need to write it as 5 times x plus 5 times 3. Or maybe we'll have -6 times the quantity 4 minus y. So we take -6 times 4, which is -24. -6 times -y is a +6y. So here are our properties of numbers. Again, in a nutshell, some authors spread it out as though there's, 10 or 15 or 20 of them. Some will, I don't know that they can condense them any more than this. But again, I won't quiz you over the vocabulary shown here. And in terms of actually doing problems out of the textbook, they will mostly be following this property here. But if you read in the book that it talks about the associative property, or if I mention the commutative property in a step, you need to kind of be able to keep track of which one is what, what it is that I'm talking about in that step.